Hello everybody. Today we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is practice problem 1.8 and the question is if an electron beam in a TV picture tube carries 10 power 13 electrons per second and is passing through plates maintained at a potential difference of 30 kilovolts, calculate the power in the beam. And the answer is given. Okay, let's solve this problem. So for this we have to look at what are all the data given. So it is given as 10 power 13 electrons per second. And another thing is the plates are maintained at a potential difference of 30 kilovolts. So it is voltage, right? Potential difference. So it is 30 kilovolts. What is asked? We are asked to calculate the power. We know the formula, right? For power, P is equal to VI. V into I. We know that this V value is directly given 30 kilovolts. So it is 30 into 10 power 3 volts multiplied by the current. But the current is unknown. It's not directly given. But it's given indirectly. So we need to first calculate I, then substitute that I value here. Then you can calculate this power. So what's the formula for I? I is equal to dq by dt, rate of change of this charge. Even this charge is not directly given here. Number of electrons per second is given. So if number of electrons are known, then we can calculate the charge. Charge is what? It is nothing but Q, isn't it? It is given in coulombs, right? So here number of electrons per second is known. So you can go for charge per second. You can calculate the charge. So number of electrons is given as 10 power 13, isn't it? Suppose one electron is there, then its charge is equal to minus 1.602 into 10 power minus 19 coulombs. Understand this. If you have only one that electron possesses a charge of minus 1.602 into 10 power minus 19 coulomb. But here we have actually 10 power 13 electrons. So how much charge that beam possesses? So you have to just multiply. So 1.602 into 10 power minus 19 coulomb multiplied by that number of electrons 10 power 13, that much coulomb it is having, right? So this is equal to minus 1.602 into 10 power minus 6 coulombs. So this much charge per second, right? Charge per second, because it is given number of charges passing through per second. So if you have this Q per time, that gives you the current. So once you calculated the current, now you can substitute that I value into this power equation. So P is equal to 30 into 10 power 3 multiplied by this minus 1.602 into 10 power minus 6. We got this minus sign because of the negative charge of the electron. And in the current, if you have this minus sign, that indicates the current is flowing in the opposite direction. So if you want, you can actually omit this. Otherwise, if you want, you can keep it. Okay. So that is equal to 48.06 into 10 power minus 3. So this indicates minus 48.06 milliwatts. So here this minus sign indicates it is supplying power, right? Okay, thank you. Hope you have understood.